Okay, can you see my screen, everyone? Zahin, can you see my screen?
Yes, Doctor.
Yes, Doctor.
All right. So before we begin our session, we start with umur kita Al-Fatihah. Okay, this is just a revision for you before the test 1. So this is about the hydrostatic chapter. All right, this is the curved surface. So I give you 5 minutes. Please try to do on your own. Okay.
Doctor.
Yes.
May I ask you for a favor? I have one question regarding this topic. It also came in the quiz. I'm still confused about it because the quiz had answers, so I somehow messed the answer and got correct. Can you draw a shape on the page, or can we do it after 5 minutes?
Yeah. Okay. Yeah, have you discussed with me before?
No, I didn't discuss about that particular question.
Okay, it's okay. Please stick to the meeting because
Okay.
every one of you need to solve this one. Okay.
Okay.
We do it this together. First, I give you 5 minutes to try this on your own. Okay. Because if you cannot do this, I'm not sure because this is fundamental. I just give you the simple of the problem. This is very simple.
Soalan ni kat mana, Doktor?
Dekat sini. Boleh tengok tak screen? My screen. Can you see my screen?
Ya, saya tak nampak. Sekejap.
Can you see my face?
Okay, dah nampak dah.
Okay. So the quarter circle, this is quarter circle gate. BC hinge at C. Find the horizontal force P, which is hold the gate, required to hold the gate stationary. The width B, alright, which is into the pitch, is 3 meter. Neglect the weight of the gate. Alright, let's say the gamma here is 9790. Adam Saiful dalam kereta pun boleh belajar. Okay.
Serius ni?
Okay, tak apa, awak dah pro. Okay. So how to solve this one, everyone? Okay, remember that when we have the curve, how many force that we need to involve here? How many force? If this is curve. It is?
We have a horizontal and the vertical, and
Yes.
there's no to avoid the weight of the gate, so no weight of the gate.
Yes, perfect. So we have two forces, horizontal and vertical. Okay, for curve, we have the FH and V. If straight, we only have one force. Okay. So this definitely we require two forces to calculate the P. Alright, so the first step by step, let's calculate the force. Okay, we have the pressure here. So this is the pressure force which is perpendicular to the plane. And let's say this is F. And we need to separate into FH and FV. Okay, so far you guys understand, yeah? So how to calculate the FH? What's the formula of FH? Which is gamma HC multiplied with area. This is the basic equation. Okay, the gamma is the specific weight of the water, which is 9790. Okay, HC, what is HC? HC is the height from the surface of the water to the centroid of the plane. Okay, for this part, I want you to pay close attention. Okay, when you involve of the curved surface, you need to include the projection. So this is curve. In curve, you need to include horizontal projection and vertical projection. This is very important. So when you deal with the force in the horizontal, you must look at the vertical projection. When you do the force in vertical, you must look at the horizontal projection. It is vice versa. Why? Okay, this is the reason. Okay, where is your force? Your force is horizontal, right? FH in this way. So it is your eyes supposedly facing this way. Alright, parallel to the FH. So when your eyes is parallel to the force H, so that means it is vertical projection. Okay, you can see it is a vertical projection. So let's draw the vertical projection. This is vertical projection. Alright, so this is the centroid. Okay, the centroid is acting at the center of the rectangular. Okay, you can see this is quarter circle. When you look at from your eyes here, what do you see? Definitely you will look at like this, right? Imagine yourself, your eyes is here. So you look at for the vertical projection, that means the gate will be like this. Okay, so far you guys understand? Azman, faham? Abdullah,
Faham, betul.
okay. Abdullah, Ibrahim, do you understand? Do you understand about the projection, yeah? So, HC start from here to the centroid. So, what is the value of HC? This is 2. So, HC is equal to 1.
1.
Okay? So, multiply with 1. Area, what is the area? Area of this. What is area of this? This is 3 meter, okay, into the page. So the area is 2 multiplied with 3. So what the value of FH? It is 58740 Newton. Okay, guys, you guys understand until this part? Okay,
Yes.
now we proceed to FV. So look at FV. This one. So when you look at FV, look at the horizontal projection. So this is FV, this is your eyes. So what do you look at from your eyes point of view? You see here, right? Okay. So you look at here. Okay. So what is the force in the vertical direction? Definitely the weight of the water here, right? The weight of the water here from the surface until here. How to calculate the weight? This is the weight of the quarter circle. So how to calculate the weight? So force equal to mass multiplied with gravity. Okay. I know, I'm really sure you know of this. F equal to weight. Weight is a mass multiplied with gravity. Okay. So we know that the mass is the rho multiplied with volume multiplied with gravity. So rho with the gravity we call as a gamma. Volume is volume. So we can simplify gamma of fluid multiply with volume. Okay? So from here, the gamma of fluid, which is 9790, multiply with the volume of this. So what's the volume of this? Let me draw you the volume. So anyone, how to get this volume?
Volume of quarter of circle.
Yes, multiply with, that is not volume of quarter circle. The area of quarter circle multiply
Multiply with
with,
the perpendicular.
yes, with the, so you must find the area here first. So this is area of quarter circle, which is 1/4 quarter circle. Circle is pi r squared. Multiply with 3 meter. This one. Okay. So from here, pi multiply with radius, which is from here to here is
square.
radius. So 2 squared over 4 multiply with 3.
3.
So what's the value? The value is 92268.58. Okay, now we already have the two components of forces, FH and FV. So how to get the force, horizontal force P? Okay, how to get the horizontal force P? Ibrahim, can you, Ibrahim Al-Barkoli, can you mute your, okay. So from here, we need to find the force P. So how to get the force P? We need to apply the momentum. Sorry, we need to apply the moment. Okay, summation of moment at point C. Okay, you know already at point B and C we have the reaction force. Why we have the reaction force? Because we have the hinge. Can you see? The hinge at C. Okay, that means we have the reaction force at C. So if we have the reaction force at C, that means we have two components. which is reaction force in the y direction and reaction force in x direction. So we have additional two forces. So what to do? We can cancel this force by putting the summation of moment at point C. Then we can cancel out reaction force at point C. So far you guys clear about this? Okay. So from here, let me draw you the quarter circle here. Okay. All right. So we have the force P, and then we have the F H, and we have here F V. Okay, and then this is point C. All right, so how to get the summation of moment? So just apply summation of moment counterclockwise, positive, at point C equal to 0. Okay, so in order to point the coordinate at point C as the origin, you need to know the length because moment is force multiplied with length. So from here, C to P, okay, this is action line. So from C to P is 2 meter. You already know the length of P. How about the FH? Do you know the line? Do you know the distance of FH from C, everyone?
1.
Okay. That is centroid. Remember that I told you before, I taught you before this one? Okay, in order to find from the surface, okay, this is reference line to the horizontal force.
We have to find the YCP.
Yes, perfect. We must find the YCP, which is negative I XX sine theta over HC multiplied with area. So this case, we look at the vertical projection. Where is our vertical projection? This one. Okay, our vertical projection, what's the shape of the vertical projection? The shape of our vertical projection. It is rectangular, right? This is rectangular shape. So when we look at the XX component for rectangular, it is 1/12 BH cubic. This is the formula. So the H is always, okay, this is your coordinate point. Okay, like this. So this is X and this is Y. So your H is always parallel to the Y axis here. So in this case, this is your H and this is your B. All right. So YCP is equal to negative 1/12 B, which is 3 meter, multiply with 2, the cube, sine 90. Because why 90? Because this is the surface. Okay, you can see this is our projection plane. So from the horizontal, it is 90. So sine 19 over HC. HC is height of the centroid. So what's the value, which is 1. Multiply with the area of this vertical projection, which is 2 multiply with 3.
Boleh.
So you will get negative, okay, 0.333 meter. So what does it mean? YCP negative means it is below the centroid. Where is the centroid of this? From the surface, it is 1 meter, right? From here to here is 1 meter. So how to get the HCP? The HCP is the height of the horizontal forces. This one. This is HCP. So definitely this 1 meter plus this value 0.333, which is 1.333. So your F, this is the YCP. YCP. Yeah, because it is below. When it is below, you have to ignore the negative, because negative mean it is the sign notation only. Okay, from here to here we know already it is 1.333. Okay, from here you can see the line of action here. Okay, this is the line of action. Okay, from here to here, line of action FB. You need to know the distance here. Okay, this is actually the standard distance of the quarter circle centroid. Okay, where the value here is, if you look at the table, the centroid of the circle is C equal to 4 R over 3 pi. Okay. So C here, 4R. R is 2 meter radius over 3 pi. You will have the value equal to 0.8488 meter. So now we have all the length, then we can solve the value of P. So apply the summation of moment at point C here, okay, equal to 0, because this is equilibrium. Okay, we start at P first. The P moving from here to here. So the C going here. So P, you try to use your right hand rule. Okay, from here going to here. Okay, multiply with this. So this going to here. You use your right hand rule. Can you use your right hand rule here and then try to rotate? Your thumbs facing into the page or out of page. Your thumbs. Can you try? From C and then go to P. Your thumbs is positive or negative?
Negative.
Negative. Okay. So negative P multiply with 2. Okay, understand, yeah? This sign notation. Okay. And next, your F. Okay, we try to use the FH. Where is the FH? This is FH. This is the line of action FH. And this is your C. Your C here, going here. So is it positive or negative? From C going to FH.
Positive.
Positive. So positive FH, we discovered before This is FH 558,740. Okay. 58,740. So what's the value here from here to here?
2 minus YCP.
Yes, perfect. 2. The total here is 2 minus here. 2 minus HCP. So here 2 minus HCP is here. And finally FV. So this is FV, this is your line of action. And this is C. So C going to V. Is it positive or negative?
Positive.
Positive. So from here to here, you can see your arrow. Sini, it is positive. So positive FV, the value is 9268.8. Sorry, 0.58 multiply with this length, which is equal to this one, 0.8488, equal to 0. And finally, you can solve the value of B is equal to 58748.6 Newton. That is the final answer. Okay, so far, do you have any question? Anyone? Okay.
Doctor,
Okay.
I'm referring. I want to ask a different question. It's kind of same. Can you draw a shape in which the bottom part of the shape is the top and the top is the bottom?
Okay. Is it like this?
Yeah. So can you draw the complete shape? I mean,
Okay, like this. Okay.
yeah. So if the curved surface is at the top, not at the bottom, the area we will use, is it also the curve? Because the force acting on the water, the weight of the water is acting downward.
From here. From here. So you have two forces lah.
Yes.
Okay. So you must calculate the FV. You know how to calculate the FV?
Yeah. So yeah, no, that's my question for the FV, the weight of the water. So should they include the because
Okay, I understand your question. This is the water, right? This is water. Inside here is water, right?
yes, Doctor.
Okay, so you must assume, okay, there is a external force. Okay, counter it in order to make it balance. Okay, so this force should be equal to this force to make it balance. So it is easy. Just assume inside here, out of here, we have water. Okay. Okay. So in this case, I know you have trouble to find the FV because FV is the empty of water, right? The empty of air. So for this case, okay, we have the water. Okay, even this is not water, just assume we have the other water here because we need to counter this force. So just take this way. Okay, This is the rectangular part minus this part. And then you will have this water section. Okay. Do you understand, Ajmal?
Yes, doctor, I got your point.
Okay,
Because
and then because this is needed to counter back. So you need to assume we have the water. Okay.
yes, got
Okay, so answering your question, yeah?
yeah.
Okay, so we proceed to the next question. Okay, this one. Okay, I give you 3 minutes to do on your own first. At least draft and understand. Because you need to understand this fundamental. Alright, in order to do in your test or do in your final, not only for your test, but apply any other examinations. Okay, all fluids at 20 degrees Celsius. Okay, determine the pressure difference. Normally, what we call this, we have the tube, the U tube here. What we call this, the manometer. Okay, please understand, this is manometer. When you have this kind of manometer, please use my concept. This is a very important part. Okay, the first step, what you need to do, you need to label it. Okay.
Yeah.
You need to label and find the reference line. Okay, from here, this is your benzene. And here is your mercury. From here is kerosene. From here is the water, and this is air. The question asks to find the pressure difference between point A to point B. So the most important thing, please label it first. Okay, so this is your line. Okay, this is A, this is B. We use other notation. For example, this is 1. Okay, and then this is jump here. From here, we jump here because this pressure and this pressure is the same. We can jump. Okay, this is point 2. And then here, this is 3. Okay, so from here, so this is 4. 4 same with 5. And then we have here, this one, this pressure same with this pressure. Let's say this is 6 and this is 7. Okay, so far you guys know how to make this line. This is very important. Okay, let's say, let me recap first. This is point A. You must start from here. From here, you move from here to here. Okay, first you start from here. Mercury, you look at from the other side. Okay, this is different, this is nothing. So make it the line here. So this is 1, this is 2. Okay, and then this is definitely we have the stop, the limit, our mercury. So it's okay from here. This is the limit of the mercury, and then you look at here. This is the limit. You cross this limit. Okay, you see this is limit. You cross this limit. Or in other words, let me write it down for you. Okay, look at here. This is the limit, right? Okay, this limit. Okay, this limit. Okay, this point. Oh, this point. The same with this point. Okay, this is the. Okay, this is the final lah. Okay, so you can see this is limit. Okay, cross this limit. Look at the other side. Okay, this limit. Look at the other limit here. Alright, so now you know how to make the line of the limit. and then label it. So this is A, this is 0.1, this is 0.2, this is 0.3, this is 0.4, of course this is 0.5, this is 0.6, this is 0.7. Okay. Alright, and then we start with the manometer equation. This is very important. So start from A, go to 1. So P minus 1 or PA minus 1? Anyone? P? If we start from A to 1, that means 1 minus A. Okay? Final minus initial. So it is negative. This is hydrostatic equation. Gamma, okay, Z1 minus ZA. Okay, so Z1. How to get the Z1? So this is, alright, after we label this one, let's say we put here as our reference line. Okay, this is 0. From here to here. Okay, you can see Z1. Z1 is the same location with the reference line. So what's the value of Z1? It is 0, right? The Z1 equal to 0 because Z1 here, the point number 1 is at the same line with the reference point. Okay? So gamma. So this is gamma of benzene. So what's the value of gamma benzene? It is given that it negative 8640. Z1 is 0 minus ZA. ZA is here. So from 0 to 20 centimeter, it is 0.2 meter. Up until here, you guys understand? Everyone?
Yes.
Yes. Yes.
Okay. So after from point A to point 1 and then 1 to 2. Is it 1 to 2 have the same pressure?
Yes.
Yes. Point 1 and point 2 will have the same pressure. So you can skip this section. You jump across. So point 2 to point 3. So P3 minus P2. Negative gamma. So this involved of this fluid. This is mercury. So Z1 is Z3. Follow this one. Minus Z2. So negative mercury, which is mercury. This one. 133,100. Z3. What's the value of Z3 from the reference line, which is 8 centimeter. So put it with 0.08. Okay. Minus Z2. Z2 at the same reference line. So it is minus 0. Okay, this one I try to solve for you, yeah. 7 to 8 Pascal. You solve, yeah. Negative 10648 Pascal. Okay, from point 2 to point 3. Okay, now, okay, point 2 to point 3. Okay, now for point 3 to point 4. P4 minus P3. So, negative gamma of, this is liquid of kerosenes. So this is kerosene. Z4 minus Z3. So negative kerosene is
7.885.
7.85. Okay, Z4. What's the value of Z4?
For
0.4
4.
minus Z3. What's the value of Z3?
8.
0.8. Yes, you must make sure it is correct. Otherwise, you put 0.8, your unit is wrong, then you get the final answer wrong. Okay, you solve this one, you will get negative 2523.2 Pascal. Okay, and then we move to 3 to 4. Okay, 4 to 5. Do you need to do 4 to 5? No need, because 4 and 0.5 have the same pressure. So jump to 5, 5 to 6.
6
Okay, P6 minus P5 equal to negative gamma. What the liquid involved? Water.
water.
So Z6 minus Z5. So negative of water, which is 9. Where is water? Okay, 9790. Okay, Z6. What's the value of Z6? Z6 same with 14 centimeter. Everyone?
14.
Yes, sir.
6, 7, the same line,
0.14.
right? So 0.14 minus Z5. What's the value of Z5? Which is
0.4.
0.4. Don't worry, you will get negative. You counteract negative, positive. So 2, 5, 4, 5.4 Pascal. Okay, finally, 6 to 7, not necessary to do because 6 and 7 the same. So 7 to B. So PB, final minus initial. So negative of gamma of what? Of air. ZB minus Z7. Okay. The gamma of air given 11 point negative 11.77. So ZB, what's the value of ZB? From the reference line, 23 centimeter. Okay, because 14 plus 9, 23. So 23, 0.23 meter minus Z7, which is 14, 0.14 meter. You will get negative 1.059 Pascal. So how to get the pressure difference between point A to point B? You must plus the whole of this. Okay, plus. Okay, P1 and P2. Is it P1 the same with P2? Okay, you look at here. You plus P1 plus minus P2. Okay, you see P2. P2 at the same line with P1? Right, the same, right? So P2 is actually equal to P1. So P1 minus P1 cancel. Okay, guys. So P3, you look at P3. P3 minus P3 cancel out. P4 minus P5. You look at P4 and P5 at the same line. Okay, 5 equal to 4 because the same height. So P4 minus P5 at the same height. So it is the same pressure, cancel. So P6 minus P7, you look at 6 to 7. The same line, right? So 7 is actually equal to 6. So this one cancel out. So what you have here, PB minus, because PB plus minus PA equal to, you plus all this. Finally, you will get okay, but the question asks, determine the pressure difference between A to B. This is B to A. So how to do? Change the position PA minus PB PA minus PB negative go to positive. Because all this you try to multiply with negative. You can see this one positive become negative, negative become positive, negative, negative, positive. Therefore, that is the final answer. Do you have any questions so far, everyone? Okay, faham tak everyone? Boleh faham? Understand? Jelas?
Yes, doctor. Understand.
Excuse me,
Okay.
doctor. I have question.
Okay, what's your question?
In case I didn't label the point 6 and 7, from 5 I go to the reference.
Which one? From 5,
I go to the reference.
go to 7. Okay, okay, 5 to 7. If you look at here, which one,
No,
yeah?
doctor. I mean from 5 I go to the reference line. Then I neglect the bottom side. Then I go from the reference line to 7.
Which one? 5, skip to 7 here.
No, from 5 I go to the reference line.
5, go to reference line, okay.
Then from the reference line to 7.
Oh, okay, so it is okay. It is the same thing with 6. Okay,
Yes.
because the height of 6 same with 7, the same thing. When you try to cancel out, 6 and 7 cancel out together. That is why I prefer if you make it this line. Okay, this is the limit. And then you look at the other side. Okay, this is the cross. This is the limit. You look at the other side, the cross. This is the, okay. This is the limit. You look at the other side, this is cross. Okay. Okay, I think that's all for today because I've covered you to the most fundamental question. I hope that you prepare for your test. Just remember, this is the closed book. That means you cannot refer any textbook, reference or lecture note. All right, you need to be honest. All right, during the submission form, okay, you submit the 3 questions. Question 1, question 2, question 3 at the same, using the same form. All right, before you submit, you need to agree with the honesty declaration form, and then you can submit. Okay, so during the test, I'm going to. Okay, Zafira, do you have any question?
Doctor, so will the questions somehow a manometer and pressure in a dam? Will it be like that? That harder question, I guess.
Okay, I give you tips lah. The fundamental is there, but you need to apply. Okay, that means apply to any kinds of object. Okay, that is important. Okay, so you need to know this fundamental, the manometer. This is very important, and then you must know how to do this. And then the rest is up to you. Okay, it depends on your fundamental. That is why I need you to first brush up your fundamental. Secondly, do the revision to do the other question type. Okay, so far, anyone have any question?
Doctor, do you have any past year question?
Okay, basically the test will not be the same with the final because this is our rule because of the new guideline. So please don't focus on your final because the question will not be the same at all. Okay. Doctor, which topic will be covered? Okay, week 1 until week 6. That's it. Okay, you need to be prepared. Week 1 until week 6, that cover the buoyancy, the Bernoulli equation, the hydrostatic force, the property of liquid, the gamma, what is gamma, and then how to calculate the vertical plane force, the projection, the horizontal. Okay, that is the fundamental. Okay, Syahidul Islam. Week 1 until week 6. Okay, thank you. I think that's all. Good luck and all the best. Please be prepared for the application. Apply your fundamental. Okay, so I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Okay, Doctor.
Okay.